Hey everyone, it's Bradley Bush with another algebra video for you. Today we are talking about rational equations. If this is your first time to my channel, thanks for coming. Hope you enjoy it. If you do, please consider subscribing and leave me a comment. I'd love to hear your thoughts. What is a rational equation? Well, a rational equation is an equation that has rational expressions in it, meaning fractions. Rational expressions are fractions that have polynomials in the top and in the bottom. So a rational equation is an equation that has more than one or more than one rational expression in it. Some examples, we have x over 5 plus 3 equals x plus 1 over 2. Another example would be 5 over 2x equals 17 over 18 minus 1 over 3x. And a final example would be on the left side of the equation, 3 over x, quantity x plus 6, plus 1 over quantity x minus 2. On the right side, we could have 4 over the product of two binomials. The first one is x plus 6, and the second one is x minus 2. So there are a bunch of different, they're really limitless numbers of options you can have. But you can see that we have rational expressions and we have an equal sign. So that gives us a rational equation. How do you solve a rational equation? Well, there are lots of ways. We generally use the rules of algebra, if we're doing it by hand, to isolate the variable. And what I mean is, a great way to do this is to multiply each side of the equation by the LCD. LCD being the least common denominator. The reason we do that is because we clear all the fractions in the very first step. And then after that, we just have an equation that we solve without fractions. That makes it a little bit easier. If by chance there isn't a solution, then we say the solution is the empty set. And the symbol we use for the empty set is that 0 with the slash through it. Let's try a first example. Example A here says, solve the following rational equation. First, we need to find the LCD. What is the LCD? Well, if we looked at all of the denominators, we have an x, we have a 5, and we have a 2x. We need something that each of those can divide into, so that when we multiply through, everything gets canceled. So if we use 10x, then if we multiplied 10x by every term, there would be something in 10x that would cancel everything. So let's try that. I think that that'll work. And we don't want to make the LCD so big that we have extra stuff in there that we don't need. So we want the smallest thing that'll do the job. So let's try 10x. And let's multiply both sides of this equation by 10x. When we do that, we can see on the left side that the x's cancel, and we just get 10 times 1, which gives us 10. On the right side, when we are multiplying through, we get 10x over 5. Well, it's a terrible 5. Let me try that one more time. And then we get 10x times 3 over 2x. Let's just write that out. We have 3 over 2x times 10x. Now let's do some simplification here. The 10 and the 5 can make 2. And on the right, we have the 2 and the 10 can make 5. And the x's go away as well. So we can see that we're left with an equation. 10 equals 2x plus 15x. Nope, just 15, because the x is gone. And now we simply solve. That's it. We solve for x. So let's take 15 to the other side. We can see that we cancel out the 15, and what do we get? -5 equals 2x. We can divide both sides by 2, and the 2's cancel on the right, and we get x equals -5/2. Now we want to check our answer because we could have created a solution that is fake, meaning an extraneous solution. Whenever you multiply both sides of an equation by a variable, you have the possibility of introducing a fake solution called an extraneous solution. Also, there are solutions that are not allowed because they are not in the domain of the function. If we look at our function, only x equals 0 is not allowed because that's the only value that would give us a 0 in the denominator of the original problem. But we do need to check -5/2. So let's check it right now. Let's check x equals -5/2, and we'll plug it into the original problem. So the original problem was 1/x, and x is -5/2 equals 1/5 plus 3/2 times -5/2. Now we do some simplification here, and let's come up to the right. The 1/-5/2, we flip that and multiply, so we get -2/5. And we have 1/5 plus the 2's can cancel in the denominator. Here we get -5, so we have -3/5 here. And 1/5 minus 3/5 is 2/5. So that does it. So we have -2/5 equals -2/5. So we verified that that is an actual solution, so that works. Let's move on to our next one now. Our next one, example B, is x over quantity x minus 3 equals 3 over quantity x minus 3 plus 9. Luckily for us, the LCD is simple here, just x minus 3, because that's the only thing we have in any denominator. So if we take what we have and we multiply it by x minus 3, let's write out what we have again. 3 over x minus 3 plus 9, and we're going to multiply everything by x minus 3. And on the left, everything cancels and we just get x back. On the right, when we multiply through to the first term, the x minus 3 and the x minus 3 cancel, and we're just left with 3. But let's write everything down so you can see. So 3 over x minus 3, and we have a 9. So we're multiplying x minus 3 on both of these. Now we can easily see that the x minus 3's cancel on the first term. On the second, we just have to distribute the 9 through. So we get x equals 3 plus 9 times 3 is 9x, and 9 times -3 is -27. Now we just solve the simple equation. Let's get everything, all the x's to one side and all the variables to the other. Let's take all the, well, 3 and -27, that gives us, let's simplify one more step, -24 plus 9x. Let's take the x to the x's to the right. So let's take the negative, let's take the x on the left over. So we subtract it away. and now we have 0 equals negative 24 plus 8x. And let's divide, let's add the 24 to take it to the right. And it cancels on the right. Let's take it from the right to the left, Now we have 8x equals 24. And we can divide the 8 away. And what do we get? Well, 8's cancel and we get 3. So our answer then is x equals 3. Now if we go back up to check, because we always need to do that in these types of problems, we can see that we have some issues. So let's just write it out here. What we have, 3 over x minus 3 plus 9. And instead of having an x, we're going to put in our answer, which is 3. So right away you can see there's some issues, right? Because we have x over 0 equals 3 over 0 plus 9. We can't have zeros in the denominators. So 3 is not in the domain of this function. So we can't use 3, even though that was our answer. That was an extraneous answer. Our answer is the empty set. There is no answer, no solution to this problem. Let's try another one. Here we have 3 over x plus 3 equals 5 over quantity 2x plus 6 plus 1 over quantity x minus 2. What is our common denominator? Good question, right? Well, if we factor out a 2 in the first term on the right, we get x plus 3. So it looks like we have x plus 3's. We have an x minus 2. And we have a 2 hanging out. So that will get everything if we use that as our common factor, our least common denominator here. So let's do it. Let's write down our original. So we have 3 over x plus 3. And we have 5. I'm going to actually skip a step here, since you know what we're going to do. And I'm going to distribute the common denominator through all of them right at the beginning. So I have 1 over x minus 2. So if we distribute that common denominator, or multiply it, then we have 1 in the front here, so we have x plus 3, we have x minus 2, and we have 2 there. Let's multiply it through the first term on the right, so in other words, I've taken this and I've multiplied both sides by the LCD. And then I'm just distributing it through each of them. So I have 2 times x plus 3 times x minus 2. And I also have that on the right here. So 2 times x plus 3 and x minus 2. Now let's see what cancels, because we're going to have some cancellation here. X plus 3's cancel. On the left, on the right, we have the 2 and the x plus 3 cancel. And in the first term, on the second term, we have the x minus 2's cancel. Now gathering what we have left, we have a 2 times 3 times x minus 2. And on the right, in the first term, it looks like we have 5 times x minus 2. And on the second term, we have 2 and x plus 3. Now we continue with our simplification here. And we have 2 times 3 is 6 times x minus 2. We can multiply the 5 through the first term and multiply the 2 through the second term. 5x minus 10 in the first term, and the second term gives us 2x plus 6. Let's also multiply through the 6 on the left. So we have 6x minus 12 equals, we have 5x and 2x, which give us 7x, and negative 10 and 6, which give us negative 4. Let's move everything, all of the variables to the right and all the constants to the left. So that means negative, we take negative 6 both sides, so we can move that negative 6 over. Struggling with my x's. So we get negative 12 equals x and then minus 4. And now I add 4 to both sides to get rid of the 4 on the right. And I get x equals negative 8. Now I need to check, right? Let's come over here and check it. So if I'm checking x equals negative 8, then I have my original, which is 3 over x plus 3 equals 5 over 2x plus 6 plus 1 over x minus 2. And instead of having an x, right, I need to plug in my answer, which is negative 8. So I'm going to plug negative 8 in everywhere. And let's do some simplification now. Negative 8 and 3 gives negative 5, so we have negative 3 over 5 equals 2 times negative 8 gives us negative 16, and then we add 6 to get negative 10. 5 over negative 10 is negative 1/2. But actually, maybe I should keep it negative 10 because it looks like I'm going to have another fraction over there. Let me start that over. So negative 5 over 10, and I have here negative 1 over 10. Because negative 8 and negative 2 give us negative 10. So if we keep going, we have negative 3 over 5 and negative 6 over 10. We can simplify the negative 6 over 10 because the 6 is 3 times 2, and then we have negative 5, or positive 5 times 2, and the 2's can cancel. And what do we get? Negative 3/5 equals negative 3/5. So we have verified that that x equals negative 8 is a valid solution. And we're done with this problem. Let's try our last one. All right, here's our last one. This is example D. So for example D, we have 6 over quantity x plus 3 minus 5 over quantity x minus 2 equals negative 20 over quantity x squared plus x minus 6. Finding our common denominator, we should probably factor, and here it looks like we get x plus 3 and x minus 2. So luckily that's going to be our common denominator. So that's great for us. So let's start. We first write this problem down again. And again, I'm going to do the same thing I did above by multiplying the common denominator through everything first. I'm going to leave the term factored in the bottom on the right, the x squared plus x minus 6. I'm going to leave that factor just because it'll help me see what's going on. So if I have my LCD, which is x plus 3 and x minus 2, and I have that multiplied by each of these terms, x plus 3, x minus 2, then I can do some canceling here. The x minus 2's cancel in the second term on the right, on the left. The x plus 3's cancel on the first term on the left, and everything cancels in the denominator on the right. So what do we have left? We have on the left, the first term is 6 times x minus 2 minus 5 times x plus 3 equals negative 20. Now we need to distribute the 6 through and the negative 5 through on the left. And when we do, we get 6x minus 12 minus 5x minus 15 equals negative 20. And negative 12 and negative 15 give us negative 27. And we have x on the left. And then we have negative 20. Now we add 27 to both sides because we're trying to solve for x. And we get x equals 7. Now again, we need to check that, so let's do that. We have 6 over x plus 3 minus 5 over x minus 2 equals negative 20 over x plus 3 x minus 2. And instead of having an x, we're going to put 7, right? Everywhere there's an x, we put 7. Now we keep going. So we have 6 over 10 minus 5 over 5, which is 1. But we'll leave it as 5 over 5 at the moment, for the moment. Equals negative 20 over what? 10 times 5. So that's 50. So we need to make everything a 50 if we're going to compare these two. So this needs to be multiplied by 10 over 10, and this is 5 over 5. Now what do we have? 30 over 50 minus 50 over 50 equals negative 20 over 50. One more step. We can combine the numerators because the denominators are the same on the left. So 30 minus 50 is negative 20 over 50, which is what we have. Negative 20 over 50 equals negative 20 over 50. So we verified that x equals 7 is in fact a solution. So that's how you would solve a rational equation. In general, I think the easiest way is to first clear the fractions by multiplying everything by the LCD. And then what you do, you just have a simpler equation that you can solve, and then you check the solution to make sure you don't have an extraneous solution. Hope that was helpful. Have a great day.